first part we are okay. Now this is not true. Now let's look at this. Cosec 60 is 160. Now again we got to understand what is cosec 160 is gonna be. So cosec 160 is gonna be 1 upon sine 160. Okay. Now sine upon 160. Now we know that sine theta in the second quadrant is gonna be positive. So then sine theta is gonna be positive, meaning that sine 160 degree is gonna be greater than minus 1, it's gonna be positive, right? So it's gonna be greater than 0 and less than 1, right? Could be, we know that it will become 1 when this is gonna become 90 degree. Otherwise, it's gonna be between 0 and 1. So this quantity is gonna be greater than 1 for sure. But how big it is gonna be is the question. But doesn't matter. All that we are looking at is that this quantity is gonna be greater than 1. Okay. So what we are looking at is that is it gonna be positive? If it is gonna be greater than 1, then this quantity is log 10 to the base 1 is gonna be 0 at 1. Other than that, if it is gonna be greater than 1, then it is gonna be positive itself, right? That too. I mean, what we mean here is let's keep a check on that. So this is what is your function, right? So here it is gonna be 1, right? Now, this is the point where it crosses this. Right? This is the point it crosses this. So at x is equals to 1, this becomes 0. And then it becomes, after that, it becomes positive, right? So anything less than 1, it would be negative. For anything greater than 1, it would be positive. So that's the only thing which we have to look at. So this is going to be positive. This is going to be true. Okay. Okay.
Yes,
Now,
sir.
now let's look at option A and D. Okay. So one by one, we'll look at the options here. So we'll first look at D because this is looking okay to solve with. So I can just use change of base and I'll write this as log sine pi by 5. Okay. Upon log root 5. Log root 5 can be written as, anyways, let's do it in 2 steps. I can write it as log 5 and I can write this as log sine of pi by 5 root, right? So I can write this as log sine pi by 5 and this I can write it as 1 by 2 log root 5, log 5 because this is 5 to the power 1 by 2.
Yes, sir.
Similarly, I can write this as 1 by 2 log sine pi by 5. So now this and this cancels, this and this cancels. And then what I've got is 4. 4 is a number. Satisfies to an irrational number is not true. This is a rational number. Okay. This is not
Yes.
true. Now comes the last bit. Alright. So let's look at the last one. So here too, what we'll do is we'll try using the change of base root. So what is happening is this is for multiplication, 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 right? So let's use change of base root. So log 19 upon like log 3 into log 3 upon log 1 by 7. Log 1 by 7, 1 by 7 is cancelled. Okay. Now log 3 and log 3 is cancelled. What I'm having is log 19 to the base 4. Okay. Now look at this. This number is actually greater than log 16 to the base 4. Why did I look at that? Because 16 is nothing but 4 square. So this is 4 square to the base 4, which is nothing but 2 itself. 2 log 4 is base 4, right? So this is 2. So I can say that this number is actually greater than 2. So this is also true. How are we concluding that this is going to be greater than 2 is by looking at this 19, I'm saying that this is going to be greater than log 16 to the base 4. 16 is nothing but 4 square. 4 square is nothing but 2 log 4 to the base 4, which is 2.